Welcome to part 2 of section 1.2, translations and reflections. So I'm on page 13 if you want to follow along, and we're going to be working with reflections in this part. Let's highlight the first one. I want you to look at this equation, y equals negative f of x. So if there's a negative in front of the entire function, it's going to be a reflection over the x-axis. So what I want you to look here is, here's the x-axis. So if you were to fold it, this is the line of reflection, it would mirror on both sides. Now let's look at reflections over the y. Now this is different. It's not a negative for the entire function, it's only a negative here for x, which is the input. And then that's going to be a reflection in the y-axis. So here is where my line of reflection is. Can't draw my straight line here, right? There's my line of reflection. And if I were to fold it there, you would see that they mirror each other. Okay, now let's do some problems. Here is my original function. Now we're not dealing with the parent functions anymore. We're now having f of x be an actual, another function. So we have to write a function g whose graph is a reflection over the x. Over the x, I remember that. So when it's over the x, I have to make the entire function a negative. Make sure you're writing that all down. So I'm now going to write, change this to black, g of x, is going to be the entire function. So here's negative. Whatever this entire thing is, you need to put parentheses around it. Super important. Move it over here. The entire function. So here's my original function now. Absolute value, x plus 3, close absolute value, plus 1. Okay, this is going to be kind of tricky. These are absolute value marks. I'm sorry that they look like ones. They're absolute value marks. Okay. Now, here's what's tricky. We're going to have to distribute this negative, and you're going to want to distribute it to the 3 here, but you don't. You don't because this is one entire unit right here. This right here is one entire unit. Okay? So we're only going to distribute it. So first we're going to distribute it to this first unit, which is going to be, I'll write it over here, negative absolute value of x plus 3. Don't distribute it to that 3. But I am going to distribute it to this positive 1, which now makes it negative 1. Okay, so here's my new function. G of x equals negative absolute value x plus 3 minus 1. Okay, that should be a reflection over the x. So let's pop over the Desmos. I already typed in the original function, it's here in black, and it should be a reflection over the x. So if I did my math right, it's going to reflect over this right here. So let's put it in now. So g of x is going to equal negative absolute value, right? It's going to be x plus 3, x plus 3, close absolute value, and instead of plus 1, it's going to be minus 1. That's how you know you did it right. Because if you look at them, it is a mirror. Let me move this out of the way. I'm going to zoom out a little so you can see it. It is a mirror image over the x-axis. So great, you did it right. Okay, now let's move over to the horizontal translations, and this is where it gets pretty hairy. Okay, so write a function h whose graph is a reflection in the y-axis. Okay, now I remember if it's over the y-axis, only the input is negative. Okay, only that x. So let's do this. H of x equals, okay, so instead of this normal x right here, I'm going to write it, instead of this x right here, it's going to be absolute value. It's going to now be a negative x because only that x is changed. And then we're going to write the rest of it, plus 3, close absolute value, right? And then plus 1. All right, again, tricky because you may think, okay, I'm done now. You're not quite done because we now have to factor out this negative here. So it really looks like absolute value negative. We're going to factor out a negative from this whole thing. It's going to be x. Now this is minus 3 because we factored it out. right? Close absolute value plus 1. And I'm going to clean that up, because what that really is, it's really the absolute value of, there's really a 1 here in front, of -1, right? Times the absolute value, let's just put a times mark there, of x minus 3 plus 1. Okay, I know it's tricky. Follow along here. Now we know the absolute value of -1 is just 1. So that means that now my h of x function is going to be the absolute value of x minus 3 plus 1. Okay, hard to know if you got this right. That's why we're going to do it in Desmos. It has to be a reflection over the y. So let's pop over there to Desmos. I'm going to clear my screen here. Here's my original. Okay, now it's over the y-axis. Okay, if it's over the y-axis, I'm going to just draw it here so you guys can see this. It needs to reflect over this. So pretend that that's your fold line. And let's put our new equation in, and we're going to check it mathematically. So h of x equals absolute value of x minus 3, close absolute value marks, plus 1. I'm going to change the color so you guys can see this. Let's put it in red. Okay. There it is. So yes, it reflected over the y-axis. It's super tricky. I get that, you guys. It's super tricky. So we're going to have lots of practice. I want you to take it slowly, rewatch the video if you need to.